Hey guys, welcome back to another episode of Math Unlocked, and I'm your host, Mrs. Rhodes-Grierson. Now, what are we doing today? Today, we're looking at matrices multiplication. Now, notice I have matrix A and matrix B, and the size of the two matrices are not the same. So we're going to check out, how do I know when two matrices are compatible for multiplication? In other words, how we know if the two matrices can be multiplied. Now, it depends on the order in which I'm multiplying the two matrices. Let's check out if I'm multiplying A times B. And really, does it matter the order in which I multiply? Now, there is a rule that surrounds how to multiply two matrices. And the first thing is that if you're going to multiply two matrices, and especially in the case that I have A times B, it means A comes first and B comes second. So, from my first matrix on my left, I must highlight the rows. So I'm coming into matrix A and I'm highlighting the rows. So this is row 1 and this is row 2. That's the only thing that I will highlight in matrix A, because when multiplying two matrices, from the first matrix on your left, you will only identify your rows. Go over to B. I'm multiplying by B. From B, I will highlight columns. So this is column 1 and this is column 2. I am going to check to see if it's a possibility that these two matrices can be multiplied. So now let's look. If I'm multiplying A times B from A, I should take the rows. So row 1 will multiply column 1. Let's look at what happens here. From row 1, I'm going to use it to multiply column 1. But look at the orientation of what this is. This is horizontal and this is vertical. Now I'm going to just carry this around to show you what would really happen if I should multiply. I'm going to set this horizontally, and this was my row 1 to show. What would have been in row 1 is a 2 and a 4 multiplying. What is it multiplying? It's multiplying 3, 1, and 7. Now, I could use the 2 times the 3. I could use the 4 times the 1. But there's nothing here to multiply the 7. Why is that so? From row 1, I have 2 elements going across. So from my columns that would have been in A, that would have been column 1 and column 2. There were not enough elements going across to match with the number of elements going down. And going down, this would have been row 1, row 2, and row 3. So what I'm realizing is that if the number of columns from the first matrix doesn't match with the number of rows in the second matrix, it means that they're not compatible, they can't be multiplied. I'm going to repeat that for you now. If the number of columns from the first matrix doesn't match the number of rows in the second matrix, then the two matrices are not compatible for multiplication. That means A times B would not be possible if I tried to multiply them. But what if I switched it around and the request was to multiply B times A? Now, based on what I would have told you before, remember now we said if it's B times A, then B would come to the front and A would go to the back. Now, what were the elements here? It would have been 3, 0, 1, 5, 7, 6, multiplying 2, 4, 5, negative 1. What should I highlight from B? From B, I'm highlighting my rows because B is now on the left. So from the one on the left, which is my first matrix, I'm only going to be highlighting my rows. From the one on the right, I'm going to be highlighting my columns. Column 1, column 2. Let's check out the compatibility now. From here, there are 2 elements. From here, there are 2 elements. So it means that if I should carry this on over to multiply, 3, 0 would be multiplying 2, 5. Now I can see that this is column 1, column 2, this is row 1, row 2. The number of elements would match with the number of elements here. So the number of columns matches with the number of rows here, and that means that the two matrices are indeed compatible for multiplication in this order. So what can I therefore conclude? I can conclude 2 things. I must pay attention to 1, the order of the matrix. The order in which I'm asked to multiply makes a difference because it will indicate compatibility. 1, always take the rows from the first matrix to multiply the columns from the second, and to know if they are compatible for multiplication. Check if the number of columns from the first one match the number of rows from the second one. And if it match, I can say yes. I'm going to write down the order of the matrix now to say the order or the size of this matrix is a 3 by 2. It has 3 rows and 2 columns. The order of this matrix is a 2 by 2. It has 2 rows and 2 columns. I can do a quick check on my compatibility. Now, a quick check for you. Look at the number of columns from the first one. Does it match the number of rows from the second one? So if the 2 numbers here, columns from first, match with rows from second, then I can confirm compatibility. And then I can do some quick checks after that. We can do some quick checks after that, and we're going to check one and then you're going to check yourself. I'm going to check one and you're going to check yourself. Alright, ready to check with me? Let's say I have matrix P, which is a 2 by 4, and matrix Q, which is a 2 by 4. And they say P times Q. Now I'm going to check. I know that if I multiply, I will multiply the rows. The rows from the first one, and I use it to multiply the columns from the second one. That's what I will multiply. However, to check to see if it's compatible for multiplication, I'm going to check how many columns does the first matrix have, and how many rows does the second matrix have. And to check compatibility, if these 2 numbers are not the same, I cannot multiply them, which means that P times Q would not be compatible for multiplication. So what I'm going to ask you to do is to check, is this possible? Is L times M possible for multiplication? If it is, comment if it's compatible. If it is not, also comment. But if it is not compatible, what about if I place M at the front times L at the back? Would those 2 matrices be compatible in this order? M coming first and L coming second. Have a good day enjoying the matrix, and check yourself. Would you be able to provide the information whether or not these 2 matrices are compatible for multiplication? See you in the next video where we actually multiply 2 matrices.